Hey everyone, welcome to AV channel. Today we are going to solve the problem of searching an element in a 2D matrix. This is problem number 240 in LeetCode. So if you see here, given a matrix, the matrix has the following properties. The matrix has a list of integers, so the matrix can be an m by n matrix, and in the integers in each row are sorted in ascending order from left to right, and at the same time integers in each column are also sorted in ascending order from top to bottom. So this matrix has a special property that if you see in the first row, the elements are sorted from left to right in each row. Similarly, the elements are sorted in top to bottom in each column. So the brute force approach will be like you iterate through all the elements and then try to search it, but we are not making use of these two properties, searching the elements in a sorted rows and sorted columns. So this goes through making use of these properties using binary search, the way we search the binary trees, right? So we should be able to solve this one with that approach. So let's discuss about the algorithm. So the algorithm looks something like this. Suppose what happens is, let's say in this case we have to search for target as 5 in this given matrix. So if you start from the top left and top right, for example, if you start from the first row last column, what happens? This is 15 and the element we are searching is 5. So definitely our element won't be there in this last column because the last column is sorted from top to bottom. So this won't be there in this one. So we can completely eliminate this column. Then we go to, let's see, with 11. So we move to 11. So our search will be limited only to the this range. So in this case, if you are trying to look for 5, again 11 is greater than 5. So in this case, our elements down this one also can be eliminated. This complete column can be eliminated. Similarly, you search with this here. This is also greater than 5. 7 is also greater than 5. We can eliminate the complete row, complete column, sorry. So this is when we come here and see that if this property, this element 4 is greater than 5, no. In that case, we cannot eliminate this one because it can be there somewhere in our column. So next we go to the next element. If it is 5, then we will return that it is available in this matrix. Otherwise, we will repeat the same process what we did earlier. So the algorithm looks first check with topmost, check with first row and last column. Compare target with first row and last column element. If it is greater than the matrix element, then eliminate. Then ignore the complete column. If it is lesser, than the matrix element, then move to the next element in the column. If it is equal, then return true. So let's write the code for this one. So here first we need to check is if matrix dot length equal to 0 or matrix equal to null, then we'll simply return false. We cannot find the element here. Else what do? We will call the recursive function, so which will start from in this case we can start from anywhere, but we will take it from first row last column. So here we will write a helper function which takes search matrix. So we'll say return search matrix, which takes matrix comma target, and the position that we are starting our search is from first row and last column. So the row will be 0 and column will be matrix of 0 dot length minus 1. So that is the last column. So let's write this function. So public boolean search matrix helper. So we'll say this search matrix helper. And matrix and target and row and column. So here so what is our base condition here? So our base condition is if matrix of row and column equal to target, then we simply return true. Else we will first check if matrix of so matrix of row column is less than matrix of row column is less than target. So in this case what we do, we will actually go to the next column. So this is the example. So here 5, this value is less than 5. So in this case what we do, we'll simply call search matrix helper and we'll use matrix target and row will be row plus 1 and column will be same. This will happen. Else we'll simply return search matrix helper matrix target. In this case what happened, so the value at the column is greater than the target. So in this case we'll simply ignore the complete column, we will move to the previous column and repeat the same process. Row comma column minus 1. So we'll simply return this one and here we'll return this one. Else default will return false. Run code. Sorry, this is not required. It's not reachable. Submit code. Yeah, so one thing we need to verify is another case where if row is greater than or equal to matrix dot length. These are base conditions where it is exceeded or row is less than 0. Similarly, column is less than 0 or column is greater than or equal to matrix of 0 dot length. So in this case it is out of bounds, so this is simply written false. Let's run the code now and let's submit. Yeah, so thanks for watching this. Please subscribe to AV channel.